Hi everyone, and welcome to our video on exponential applications. So exponential applications just involve the exponential growth formula or equation, which is usually something like this. So a of t, so that's an amount after some time t, is equal to, they usually use a, so that's a naught is how we say it. But it's an initial amount. It is also the time or the amount at time equals 0. Okay, so when t equals at, I could write it as t equals 0 instead. Okay, when t equals 0, if you plug 0 into this, that's the value that should be left over. Okay, r is called the growth rate when r is positive. It's called a decay rate when it is negative. And then t is time. Okay, so that's all of them. Sometimes they change the form of it. Sometimes they use like n of t equals n naught e to the kt. So they might change the r to k. Okay, so or any letter of t. So they can change the form, but this is usually what it looks like, something like this. Okay, so we'll use this formula whenever they tell us about exponential growth. Exponential growth grows exponentially, or if they use the word decay, decays exponentially as well. Then we would use that. Okay, so it's telling you about your R value. All right, so let's see how this works. So it says a newly formed beehive has a population of 40 bees. Okay, so let me underline that. A healthy colony has a daily growth rate of 15%. What will the population of the hive be in 30 days? Okay, so that's our time. Okay, so we're marking all this down. Okay, so because they use the word growth rate, or they use the phrase growth rate, that's implying that we should use the exponential growth formula. So growth rate, exponential growth formula. So I'm just going to write that down right there. Okay, and then these will be the letters that we can sub into them. Okay, so it does say a newly formed beehive has a population of 40 bees. Okay, so that's an initial amount, because that's the new beehive population. Okay, so that means a naught is 40. So I'm just writing them to the side, and then we'll come back and plug them into that equation. Then they say a healthy colony has a growth rate of 15%. Okay, so it's a growth rate, so that means it's positive. And it's given as a percent, but in our equation, we will need to change it to a decimal. Okay, so we will use 0.15. So all you have to do is move it 2 to the left to get that. Okay, and then t is t. So for now, this is all I need to plug in for my formula. So we're just changing the 40, or changing the a naught into 40, and then changing the r to 0.15. There we go. Okay, so that's usually the first step in these, is to use the initial information to get the formula. And then now I'm going to let t equal 30 days. Okay, so we'll plug in 30 for t. Just like that. Okay, and so this right side, it will need a calculator. Okay, so I'm currently on Desmos. Okay, however, let me click Desmos. Let's go to the scientific one. All right, so I need the 40e, raise it to, let me even do the parentheses, 0.15, and then parentheses 30. Okay, so there we go. Okay, so that's our population of the bees then. Well, we'll just round it to the nearest whole number, so 3,601. So that's it. Okay, so 3,601. So I'll even write the a of 30 is 3,601. Okay, and that's rounding it to the nearest bee. Okay, so that's how many bees would be in this hive after 30 days. Okay, so we've got 3,601 bees after 30 days. So that's how those formulas work. That's it, done. Okay, so only 30 days, and it's much bigger than 40. So that exponential growth. So if you ever hear anything growing exponentially, it's kind of like this, where just after not even that long a time, the number has skyrocketed to something big. Okay, so after 30 days, just 40 went to 3,000. Okay, anyway, so that's how these formulas usually work. All right, so let's see another one involving interest. So if there are different types of interest. Okay, so what we want to solve, or what we want to box, is right here, or at least that's the newest part. If interest is compounded continuously, we would use future value equals present value times e to the RT. Or here is that formula from above, just written using a couple different letters, like just A equals P e to the RT. Okay, so whichever way you want to use it, so that's compounded continuously too. Let me underline that, compounded continuously. If it's not compounded continuously, then we'd use the Tvm Solver, which we have other videos on too, which can be used for anything involving finance. Okay, but our focus here will be the continuously. Okay, so we'll do the monthly just to show it, but all right, so let's find out how we can solve these. So find the interest earned on $50,000 invested for 20 years at 1.2% interest compounded as follows. Okay, so let me underline some of these. So find the interest earned. Okay, so that's going to be part of the future value. What we really will need is the future value, but we'll come back to the interest on this $50,000. So that is the present value. The time is 20 years. And it's compounded at 1.2% either monthly or continuously. Okay, so this one is kind of review-ish. Okay, so the monthly, this is compounded monthly, so that means we should use the Tvm Solver. So the calculator has these, the 84, the 83, the Inspire. I'm also showing you, I'll show you the online one. Okay, but on these, you'll have certain variables. You have N equals, I% equals, PV equals, PMT equals, future value, FV equals, and then you'll have payments per year and compounds per year like that. Okay, so let me show it on mine. Okay, so here's the Tvm Solver. I just typed in Tvm Solver, and then I clicked on that one. Let's go ahead and click on it too. And then it opens up this, and then this is how it looks like also in like an 84. Okay, so the main thing too for review here is this N. The N is the number of times compounded times time. Okay, so monthly, getting compounded monthly means the number of times it's getting compounded in a year would be 12, and that's both of those. P over Y is payments per year, C over Y is compounds per year. Okay, so that's what those will mean. Okay, and we'll just fill these in. Okay, so 12, 12, and then, well, actually, let me fill out the table first, and we'll come back to this. Okay, so I have 12, and they said 20 years. The I% is 1.2, so on this program, we leave it as the percent, as 1.2. The present value is $50,000. Okay, on this, we usually do negative for present value, okay, because that's how it's programmed. On this one online, it tells you that incoming cash would be positive, outgoing are negative. So this is outgoing, so it means outgoing from my pocket into the bank. Okay, so that's why I'm making it negative. PMT is payment, so that's going to be 0 on this problem, so that would be like $200 a month every month. Okay, so something that happens frequently. And then future value is what we want to find, which I'm going to do in blue. Okay, so we need to find this. And we just put 0 as a placeholder for most of these problems because, again, that's how it's programmed. Okay, so 12 times 20, and it does it for me, 240, 1.2. Here I have negative 50,000. 0 for payment, and then 0. And then now I can just click solve for future value, and we get this. Okay, so $63,554.84. I had to click on it to see the 4. Okay, so there we go. So 63,000. Let me write that on there. Let me move this to the side. Okay, so this was reviews. That's why I was going a little fast there through it maybe. Okay, so I had to move that. Okay, so $63,554.84. Okay, so that's rounded to the nearest cent. Okay, so that's our future value. That'd be in dollars. Okay, so that's how much this account is worth after the 20 years. They said they wanted interest, though. The interest would be the difference between your future value and your present value. Okay, so that I just need another calculator for. So, or at least let me set it up. It's the $63,554.84 minus the present value, which was $50,000, just like that. Okay, so I have that. Actually, I could do this without a calculator. It is, or at least I think I can, $13,554.84. Okay, so that's the interest that was earned over that 20 years at this interest rate. Now, number 2 is continuously. Okay, so this, I hope, was a nice review. Number 2, continuously, means you just use this equation instead. Future value equals present value times e to the RT. This time around, all right, I'm going to start plugging these in. Well, I could put it to the side first. The present value we would keep as positive because we're using a formula and not a program. Okay, so 50,000. We've got the time is 20 years. And then the interest rate, R, is 1.2%, but the formula would require it to be a decimal, so 0.012. Okay, so we move that decimal over to the left twice to get the decimal equivalent of the percent. Okay, and then that way we can solve for future value. So the future value is 50,000, and then times e to the 0.012 times 20, like that. Okay, and that's where I'm going to go back to my Desmos at this point. Okay, so it was 50,000 e to the 0.012 times, so I didn't move the decimal right. Let me use parentheses. Okay, so that's why parentheses are a little better. Okay, and then parentheses 20. Okay, and that's our answer. 63,562 and 46 cents. Okay, so I've got this future value, 63,562 and 46 cents. Okay, so this is the future value, and then again it will want the interest, which is still a future value minus the present value. So that $63,562.46 will get subtracted with the 50,000, and then that would give us $13,562.46. All right, there we are. Okay, so comparing these two values, notice that our second one is a little better, so it's about $8 more. So it's a little better, right? $8 is better than nothing. All right, so a little better. So what it boils down to is the more that something is compounded, the better the interest will be. Okay, even if it's not significantly different, it's better. So imagine if it was over like 200 years, or if that was possible for us to live that long or whatever, these differences would be a little bit bigger. Okay, anyway, so compounded continuously, we use this formula. So being compounded continuously means that it is compounded like every instant. So every microsecond, something like even more so. That's what's happening instead of just once a month. All right, so that's what it means. But still, use the formula. So as soon as you see continuously, use the formula. If it's compounded any other way, Tvm Solver. Okay, but that's how we could do these problems. So the application of them is usually pretty nice because it always has this form. So if you see exponential growth, or if it says a growth rate or a decay rate, we know it's this formula. Or if it's compounded continuously, we know it's this formula. Okay, so anyway, if you do have any questions, let me know. Otherwise, thanks for watching, and I'll see you again soon.